you for joining this live session. I really appreciate it. Today, our goal is to go through post-test review, and then we'll go through some of the questions from the post-test. For each of those questions, I'll give you some times to answer the question, and then later I'll answer those questions, okay? And then this first question is, which statement demonstrates the ultraviolet UV rays are electromagnetic waves? Okay, now Yaslin just joined. So Yaslin, today, so you have just joined. Today we are doing Unit 1 post-test review, okay? And this is our first question. So read that question and try to answer it. Then where is this? Let me see. Okay. I'll give you some time to read this question and answer it. And after that, I'll answer it. Hello, Katie. We are doing Unit 1 post-test review today, okay? And then this is our first question. So our first question, and then if you see the poll, try to answer it through the poll. Let me end polling. Thank you very much. So the correct choice for this problem is they don't require medium to travel. Okay? So ultraviolet rays are electromagnetic waves, and then electromagnetic waves don't require medium to travel. They don't require medium to travel. And mechanical waves, sorry, waves such as example sound waves, water waves, and then earthquake P waves, they require medium to travel. They require medium. I'll just write medium, okay? Medium, I'll just write medium, yes. That means they require medium to travel. Now let's go to the next question. And we have just discussed about this problem, okay? So that means I'll just launch the poll, read it carefully, and try to answer it. Which is a longitudinal wave that requires a medium to travel? Move, sorry. But it's the same thing. And then you can type your answer in chat as well, okay? Okay, let me end polling. The correct choice for this problem is A, that is sound wave. Sound wave is a longitudinal wave and it requires medium to move. It cannot move in a vacuum, okay? It requires medium to travel. This question is, what is the frequency of a wave having a period equal to 18 seconds? Let me write formula for you and then you can calculate its frequency. So frequency is equal to 1 over time period. Use that formula. So we have to calculate frequency and then time period is 18 seconds. Use that formula and answer this question. And then you can use Desmos, Mathway, or any other online calculator, or use any physical calculator if you have one. And then those who will actively participate in the class, they will get extra points in your assignment, okay? So make sure to participate. That's great. Wow, nice. Let me wait another few seconds and then We'll go to the next question. Okay, let me end polling. Thank you very much. Okay, correct. No, sorry. So we are calculating frequency and time is your 18 seconds. So 1 over 18, and that is 5.5 times 10 to the power negative 2 hertz. The unit of frequency is hertz. The correct choice is B, and then all of you have answered it correctly. So let's go to the next question. And I'll answer this question, okay? And then make sure to write a note about this question, okay? A periodic wave travels from one medium to another. So it means the medium changes here. Which pair of variables are likely to change in the process? Okay. Correct choice for this problem is A, velocity and wavelength. So if the medium remains same, the velocity will be always same. Velocity will not change. But in this case, the wave is traveling from one medium to another medium. So in that case, those velocity and wavelength will change. Okay. Now let's go to the next question. I'll do this question. Okay. Okay. Let me write formula for this question and then you can solve it. Okay. A wavelength of a wave on a string is 1.2 meters. That is wavelength. If the speed of the wave is 60 meters per second, what is its frequency? We have to calculate frequency. And then velocity or speed is your frequency times wavelength in this case. Plug in all the values you have and then calculate its frequency. Okay. I have launched the poll and you can answer through poll, unmute and tell me the answer or write on the screen. It's up to you. Now let me in polling. Thank you very much. Let's plug in those value. Velocity is 60 meters per second. We have to find frequency. And then wavelength is 1.2 meters. Divide both side by 1.2. That 1.2, 1.2 got cancelled. So frequency is 60 over 1.2. That is 50 hertz. And the unit of frequency is hertz. So the correct choice is C, 50 hertz. I'll pause here for some time. If you have any question, please let me know. And if you understood this problem, please give me a thumbs up or type yes in your chat. Okay, now let's go to the next question. Hello, Matthew. We are doing unit test review, okay? Sorry, post-test review. And then think about this question. Which statement is true for a sound wave entering an area of warmer air? So that means what will happen if we increase the temperature of the air? What do you think? Think about this question. Okay. Let me launch poll again. Okay, let me in polling. Thank you. The correct choice for this problem is the wave travels faster with an increased wavelength. The correct choice is E. Let me see. Yep. E. Thank you for your participation. Now let's go to the next question. This question is about interference. Okay, and then let me explain question at first, and then you can answer it through the poll. Two waves with amplitude 52 and 98 units come together, and their amplitude when measured in a specific point and time is 46 units. That means their resultant amplitude is less than their individual amplitude. What wave behavior explains this value? Take your time and answer this question. I already got one correct answer. I encourage all of you to answer it. Okay, let me end polling. Thank you very much. The correct choice for this problem is destructive interference. In destructive interference, uh, we have to subtract. In destructive interference, the amplitude of the two waves will be out of phase. That means if 98 is positive, 52 will become negative. So the crest of 90 will match trough with trough of 52. That means like their resultant amplitude becomes 98 plus negative 52. So it becomes 46 units. Okay. But if it is constructive interference, we'll add them together and both of the waves are enough in phase. So it would be 98 plus 52. That would be 150 units. So if it was like 150 units, it would be constructive interference. But in our case, the resultant amplitude is 46 units. So it's a destructive interference. Okay, now let's go to the next question. This question is about Doppler shift. Okay. Which of these events is an example of the Doppler shifts? I'll answer this question, okay? Let me briefly explain Doppler shift. So let us suppose you can think Doppler shift in that way. The frequency of the wave will increase when the source moves towards the observer or towards us, think in our case. And when it moves away from us, further away, its frequency decreases. So that means in this case, the frequency of light from a star increases as it moves towards us. That is the example of Doppler shifts. And if the star moves further away from us, its frequency decreases and wavelength increases. Okay, now let's go to the next question. So this question is about finding the velocity of, finding the speed of the sound wave at certain temperature. Let me read this question. Chloe is playing the flute some distance away from a crowd. If the atmospheric temperature is 15 degrees Celsius, we do have temperature. What is the speed of the sound traveling from the fluid. So we have to calculate speed of the sound b. And then if you have pen and paper, make sure to write this formula. Let me write this formula. Speed of sound at T degrees Celsius is 331 plus 0.6 times T. Okay, I'll write that formula for speed of sound at certain temperature T. So now let's plug in that 15 degrees Celsius and calculate the speed of sound. It becomes 331 plus 0.6 times 15. 0.6 times 15 is 9, so it becomes 331 plus 9, 340 meters per second. So the correct choice is A. I'll pause here for some time. If you have any question, please let me know. Okay, now let's go to the next question. Okay, and this question is similar to the previous question. And then the question is, which of those factors will increase the speed of sound wave in the air? Okay, let me launch 4. Try your best and answer this question. I already got some answer. I encourage all of you to participate. Let me in polling. Thank you very much. The correct choice for this problem is raising the temperature of the air. If we raise the temperature of the air, its speed of the sound will increase. And this question is about how do we hear the sound. Okay, read that question and try to answer. Okay, let me in polling. Thank you very much. The correct choice for this problem is electrical signal waves. So in our inner ear, the sound wave will be converted into electrical signal waves and processed by the brain. Electrical signal waves, you can write that. Okay, now I'll work on this problem. The distance between a sound and listener, so sound source. Let's suppose this is sound source, okay? And this is a listener. Let us suppose this distance is R, is decreased to half. So now for next time, this distance is decreased to half. That means R over 2. What is the change in amplitude? Amplitude of the sound heard. Okay. So amplitude is inversely proportional to the square of the distance. Inversely proportional to the square of distance, okay, between source and then observer. So in this case, it becomes A dash 1 over R over 2 square. So to that 2 goes to the top. So it becomes 4 over r square. And then you can see this 1 over r square is a. So a dash is equal to 4 times a. So that means it decreases by, sorry, it increases by 4 times the initial amplitude. This is initial amplitude. Correct choice is B. This question can be a little bit confusing. Okay, so I just want to make sure that you all understand this question. Please give me a thumbs up or type yes in your chat box if you understood this question. Otherwise, I'll explain it again, okay? Or give me a thumbs up or type yes. Okay, now let me see. Okay, I think yeah, this is our last question. Now we still have around 20 minutes left. Let's see. Yeah. So now I'll put you in a breakout room and then log into your courseware and keep working on your assignment. And then I'll talk with you. And if you have any question, I'll help you to solve those questions. Okay. Now let's open breakout room. We are 4 here. You can join breakout room. Yep.